Welcome to today's ArXiv CS Digest for April 30th, 2026. We received 724 new computer science papers today across 54 subfields. Let's dive into the top picks. Trend 1 of 5. AI for simulation and robustness. AI enhances simulation accuracy and system robustness against uncertainties and adversarial attacks. This cluster covers 180 papers. Representative work includes synthetic computers at scale for long-horizon productivity simulation, an adaptive wavelet-based PINN for problems with localized high-magnitude source, and defending quantum classifiers against adversarial perturbations through quantum autoencoders. Trend 2 of 5. LLM modality and reasoning. This trend explores LLM's capabilities across diverse data types and their advanced reasoning abilities for complex tasks. This cluster covers 171 papers. Representative work includes mole tokens, modality-agnostic latent thinking, exploration hacking, can LLMs learn to resist RL training, and LLM as clinical graph structure refiner, enhancing representation learning in EEG seizure diagnosis. Trend 3 of 5. Theoretical computer science and graphs. These papers explore theoretical computer science concepts, often employing graph theory, to solve complex computational and algorithmic problems. This cluster covers 95 papers. Representative work includes computing equilibrium beyond unilateral deviation, finding irrelevant vertices in linear time on bounded genus graphs, and superpolynomial length lower bounds for tree-like semantic proof systems with bounded line size. Trend 4 of 5. AI engineering and evaluation. This trend focuses on building, testing, and ensuring the responsible and ethical deployment of AI systems in real-world applications. This cluster covers 138 papers. Representative work includes essential, yet overlooked, identity verification barriers for blind and low-vision people in government services, Intern Atlas, a methodological evolution graph as research infrastructure for AI scientists, and agentic harness engineering, observability-driven automatic evolution of coding agent harnesses. Trend 5 of 5. 3D vision and robotics. These papers explore advanced 3D scene understanding and generation, enabling robots to perceive, interact with, and model dynamic environments. This cluster covers 140 papers. Representative work includes Hermes++, toward a unified driving world model for 3D scene understanding and generation. OmniRobot Home, a multi-camera platform for real-time, multi-adic human-robot interaction, and generalizable sparse view 3D reconstruction from unconstrained images. Up next, our first paper out of 5, Understanding and Improving Length Generalization and Hierarchical Sparse Attention Models by Jieqi Leng and Yuqing Liu from Fudan University. Let's break down its key contributions. This paper systematically dissects hierarchical sparse attention models to identify 3 critical design principles: an expressive chunk encoder with a CLS token, a bypassing residual path for global information integration, and enforced selection sparsity during pre-training. By combining the identified design principles, the authors establish a new state-of-the-art for training free length extrapolation, successfully generalizing models trained on 4K context to 32 million tokens on Ruler and BABLong. The work offers theoretical motivation for intra-chunk information processing and landmark generation, providing empirically grounded design principles for developing future long-context language models. Up next, our second paper out of 5, towards neuro-symbolic causal rule synthesis, verification, and evaluation grounded in legal and safety principles by Zainab Rayhan and Holger Gysi from ASO Plattner Institute. Let's break down its key contributions. Extends a previous neuro-symbolic causal framework with a meta-level layer to address goal, misspecification, and enable scalable rule maintenance. Utilizes large language models to decompose high-level goals into candidate causes, consolidate semantics, translate them into first-order rules, and compose causal sets. Implements a verification pipeline for syntax validation, logical consistency analysis, and safety/invariant checks to ensure the integrity of synthesized rules. Up next, our third paper out of 5. Models recall what they violate. Constraint Adherence in Multi-Turn LLM Ideation by Garvin Kruthoff from Technical University of Munich. Let's break down its key contributions. Introduces DriftBench, a benchmark designed to evaluate how well large language models, LLMs, maintain adherence to original constraints during multi-turn idea refinement in scientific ideation. Findings show that applying iterative pressure for complexity in LLM-assisted ideation reliably increases structural complexity, but often leads to reduced adherence to initial constraints. Reveals a significant gap where LLMs can accurately restate constraints, declarative recall, but simultaneously violate them in their generated output, behavioral adherence, quantified by the knows-but violates, KBEV, rate. Up next, our fourth paper out of 5. The Grand Software Supply Chain of AI Systems by Carmine Cesarano and Martin Monparis from KTH Royal Institute of Technology. Let's break down its key contributions. This paper treats the AI software supply chain as a primary subject of study, breaking it down into 4 distinct architectural layers: data acquisition, model training, model inference, and a cross-cutting substrate. The research pinpoints 4 critical structural gaps in AI supply chains that are not addressed by traditional mechanisms: verifiability, versioning, observability, and traceability. The paper quantifies the immense scale of AI software supply chains by analyzing a reference stack, revealing a vast number of dependencies and lines of code involved. Up next, our 5th paper out of 5, BrainDINO, a brain MRI foundation model for generalizable clinical representation learning by Yizhou Wu and Xiaofeng Yang from Emory University. Let's break down its key contributions. Developed BrainDINO, a self-supervised foundation model trained on millions of unlabeled brain MRI slices, demonstrating strong generalization across diverse clinical tasks. Showcase the effectiveness of using a frozen BrainDINO encoder with lightweight task heads, achieving competitive or superior performance to baselines, especially under label scarcity. Establish that large-scale, slice-wise, self-supervised learning can create a unified brain MRI representation supporting various neuroimaging tasks without volumetric pre-training or full fine-tuning. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.